you very much for the introduction. I also like to hold the camera, microphone this way. This is a ballroom anyway, right? How are you, everyone? Good. The topic I have today, building enterprise advanced analytics. First, a little introduction of myself. 16 years of IT experiences and 10 years with corporate America, dealing with business intelligence and data warehousing. And then 4 years of consulting experiences with big data. Right now, I'm a practice architect for the data intelligence practice for Trace3. I'm not here to promote my company, but one thing I want to talk about Trace3 is they have an awesome marketing team to make awesome presentation like this to make me look awesome. But I'm a data engineering guy. Why am I here? You guys are data scientists or soon to be data scientists, the sexiest job ever. I feel like a nerd being invited to a fraternity party to hang out with the cool guys. So I feel honored. Then I told myself I gotta do something that'll bring some value to you guys, right? So I thought to myself, I need to talk about how to build a platform that will help you do your sexy job better. So let's first talk about disruptions. Everybody's talking about digital disruptions today. And we are being disrupted. Before you cool guys are in town, life is easy for a data engineer. And we know we have a good grasp of all the required people, process, and technology / product. That is the 3P to deliver capabilities, articulate end-to-end roadmap, and identify platforms and resources. So we're pretty good about it. And then comes big data. Big data disrupts the traditional architecture paradigm. Organizations may have ideas of an interest, we have a hunch, and we don't necessarily know what's coming out. All right? And the answer or the outcome of the initial question will trigger new questions. And it requires a new combination of skill sets and the likes of which of the new and not in abundance. All right? So the pursuit of the answer is advanced analytics. So let's dig a little deeper into the definition of advanced analytics. What is advanced analytics? First, it's the process, the tools, and the collaboration, which is, remember I talked about the 3 Ps, to enable and to drive strategic and operational decisions. People, process, and product, the 3 P. That's all about enterprise. Right? So that is something you need to remember. If I'm your teacher, I'm actually giving you points on your next exam. Predictive models are created using machine learning and deep learning to generate and validate insights and hypotheses that traditional BI is unable to discover. So that is the difference. There are limitations with traditional BI, and because of the methodologies, we are now able to do something which is called machine learning and deep learning. And also, an integral part of the advanced analytics is about the operationalization of the predictive models, so they can rapidly lay out decisions at scale. So you guys probably want to ask me a question. What is the difference between data science and advanced analytics? Well, data science is more about the models and the methodology, while for advanced analytics, it's about the framework, the models, and operationalization. Now, you may argue with me that data science is not just about the methodology, it's also about business and IT. I know, all data scientists have probably cut 3 imaginary circles that says mathematics, business, and IT, and they piece them together and put that in their head. You're totally right. But from the perspective of enterprise architecture, I would like to call out the framework and the operationalization, which I will explain a little further later. All right, this slide is actually talking about how advanced analytics is relevant to the business today. This is actually a very effective slides that we use a lot to persuade C-suite executives of our clients on why we should do advanced analytics today. But today here, we're all data professionals. We don't have to do too much convincing, so we'll just briefly go over it. This slide we need to look at it from the top right corner to the bottom right. First of all, we all have the organizational goals. The goals are still the same: increase revenue, lower the cost, right? And then we have the advanced analytic goals. We have these tools for years. We know how we're able to achieve. And then, of course, there are obstacles. The obstacles are related to data. We used to have a lot of obstacles, and things are changed today. And why is different today? Because the technology has changed. We have faster computers. We have distributed computing to make it possible to store and process a lot of the data today, and that is why we are able to make it happen, and then we can finally use advanced analytics to bring more value to the organizations. Okay, the next one is advanced analytics collaboration. As I talked about, the 3 P's, people. Collaboration is among people. And we have identified 4 kinds of job functions within the organization, which is the IT, which is the infrastructure support, and we have data engineers, we have data scientists, and also we have the line of businesses. Also, we have categorized the job functions into 4 different categories: the data management, the analytics creation, analytics operationalization, and then of course the business impact for the organization. And on the business management side, this is a job between the IT people, the data engineers, and data scientists. And on the creation of the analytics, we need the data scientists, right? And also we need the line of business to give us the business ideas and to create those models and analytics. And for the operationalization, which is the key piece where we can bring the value out of analytics, and it's a collaboration among the IT people, the data engineers, the data scientists, and the line of business. And in the end, for business impact, this is something the line of business will justify and will prove to the leadership. And of course, they need the help with data science and data engineering to help them generate the results. Wow, look at this. Data scientist is everywhere. It's truly the leading role of a movie called Advanced Analytics. I hope you guys like the movie analogy. Hollywood is not too far away, right? So, in order to pursue of a best actor in the supporting role, the data engineers actually created some strategies for the enterprise on how we want to integrate advanced analytics into the work. So let's look at the strategies. First of all, it's about information management. That is the basic. We can't talk about advanced analytics if we don't have the foundations laid down. And the foundation is all about data structure, data architecture, data management, and metadata management. And some of the key points are actually data integration and data quality. If we can fix these problems first, then we have a very good foundation to build advanced analytics on top of it. And of course, we also need to talk about data platform modernization. This is all about enterprise data warehouse restructuring and data lake platform assessment. Because the data scope has been changed. We were able to process structured data really well in the past, and now we have all these unstructured data we need to manage, and we need to get prepared. So we need to make a more modernized platform to support that. And last but not least, it's the advanced analytics. And all we talk about in advanced analytics, which I'll go into more details, are about methodology, tools recommendations, and operationalization. All right, next let's talk about the approaches. This is actually a boring slide. It's some common sense that you guys all know about. I just feel that we need to put it into the fancy terms of the architects, so hopefully it will be a little bit more convincing. There are 6 steps here. Step 1 is about establish the business context and scope. So we need to incubate the idea. We should have the idea in mind that this is something we want to do. And then we need to establish an architect vision. A vision is something that the whole company needs to agree upon, and we all understand this is the right direction we're going. All right, step 3 is assess the current state. We look at what we have today. Step 4, establish future state and economic model. We want to look at what we want to do tomorrow, right? And don't confuse the model here with the particular models you guys are familiar with. This is actually a process model. We want to use a form to make things happen. And step 5 is develop a strategic roadmap. So once we have the model, we have a goal, we want to have a detailed plan on how to get there. And Rome is not built in one day, so we will need a roadmap for us to get there step by step. And step 6 is very important, and it's being neglected a lot, is establish governance over the architecture. Once we have the plan, we need to stick to it, we need to make it happen, right? So we need to put the controls around it, so everybody can work on the same roadmap towards the same goal. So that is the approach. One thing I would like to point out from the steps is the step 2, the vision. And we want to know that the architecture development for advanced analytics is not like the SDLC, like the old waterfall process. It's actually more of a circular format that loops from develop hypothesis, identify data sources, explore results, reduce ambiguity, and then constantly refine it. And it will do the process again and again until we find the ultimate truth. All right, next is the enterprise information management capabilities. So this is something we want to talk about before we talk about the reference architect for advanced analytics. Let's look at information management as a whole in terms of data. All right. So this diagram we read from the left to the right, and we have 1, 2, 3, 4, 5 columns. And as you can see, the data in different format is acquired in different fashions. Some are batch processed, some are streaming processed, and they are stored into different type of platform, and they are being organized in between. Different processes are executed into the data, and then we have the analyze piece, which is the analytical piece we want to talk a little bit more, and then we need to decide. And the decision could be a report, a visualization, a dashboard, or something that we can implement it into the business process so we can see the results. All right, and of course for information management, the hardware is a very special piece that is needed to support the whole process on top of it. And of course, security and governance is very important, as Ms. Tamara talked about it. That's very important. And on the bottom here, we have the industry integration, which includes a lot of tools. I know it's a little overwhelming, but don't worry, we'll talk about this in detail. But the reason it's here is we want to show you a whole picture of information management and what kind of capabilities we want to implement with tools and the process. So let's move on. This is the Advanced Analytics Reference Architect. And I talked, speaking of references, I used a lot of references and some other people's slide in my presentation, but I can probably announce that I draw everything on this slide. And I searched on Google for all the logos for the products and put them here. And I only included the products that I had used hands-on or spent a lot of time doing heavy research on. And I know there are definitely products that's not up here, and I know people in the audience, you guys might be working on those products that's not here. And if they're not here, I'm sorry. Maybe it's a good time that we can talk about collaboration so I can know your product a little better. Okay, so let's take a look at this product here. Oops. Yep. Okay, let's start from the bottom left here. This is the traditional data source, the structured data from CRM, ERP, and accounting system. And they're being picked up by traditional ETL product like Informatica, SSIS package, and Oracle Data Integrator. And they are brought into a traditional RDBMS like Oracle, SQL Server, and Teradata, where this is where the traditional data warehouse is. And then on top of the data warehouse, of course, we have the traditional business intelligence tools and data visualization tools. I listed a few, there are a lot more. And these tools have been functioning really well on bringing the business insights of the data that was stored in the relational database. So that was it. Before the disruption, life was easy. Then we have, of course, today we have more work to do because for data workers, life is no longer easy because we need to work to make other people's life easy. So if you look down here, these are unstructured data. And I listed a few examples here, like click streams, like event logs and image, and social media data. Those are picked up by ETL tools that can do a little bit more than the traditional ETL tools like Paxata, Pentaho, Talon. They usually have a more, they all have a visual way for you to manipulate the data, and however, they use some of them, for example, Paxata, they use Spark as an engine so they can process the data a little faster, and then they can hook it up with big data platforms such as HDFS or NoSQL or some of the cloud storage. So the unstructured data are pulled into these big data platforms, and on top of that, we have the advanced analytics. That is the main piece of today's topic. And within this area, first we have the tools. A couple very common tools that you guys probably use and are familiar with are the R and also Python. And then we also have the library, the machine learning library, deep learning library. And we have online tools that not only is a tool, but also it's got libraries go behind it. All right, so that is the framework for the advanced analytics. The results from the advanced analytics goes two ways. One, it goes to the original BI tools and data visualization tools, so we can show the results from those models. We apply the models to production data and show them in a data visualization tool from most likely a batch work. And another direction is here. The results of the models will be used as a tool to we can operationalize it using APIs to show the results of the data in different ways. And we have Spark. We can write customized jobs, and we also have all the different tools that can make APIs easily from models. And on the far right side, we have another channel which is dedicated to the streaming process. And I listed a few tools here, like Splunk, the Data Torrent, and NiFi. Again, these are the tools that I've been working with, and they're really good in bringing insights to streaming data, and then give you real-time results. So one more thing I'd like to talk to you about is I want to show you all the interactions between different area. For example, this arrow here, the bidirectional arrow between relational database and big data platform is that the data structured data may be stored into an unstructured platform, and data from unstructured platform with good ETL process we can add structure to it and add it to a traditional data warehouse. All right, make sense? Just now I showed you a architecture which includes a lot of tools that's vendor agnostic. I try to be neutral. I want to show you how we can use different tools to help the organization to build an architecture. And it looks really fancy because of all the tools, right? And that is why I want to show you another diagram from Oracle. Oracle is still the most popular database rated by dbengine.com, and you can search it out, and it's probably the best relational database. And what they were doing in the advanced analytics world. And this is a diagram I pulled from the Oracle website, and that shows the architecture they have today. And remember the architecture from my slide reads from bottom to up. This one you actually read from left to right. And on the left-hand side, you have all kinds of data, structured, unstructured. They will put in, and as you can see, they have actually three processes. The bottom one is actually the original the BI process that the Oracle is doing really well. And then we have the middle process, which is we can call it advanced analytics. And on the top here is the streaming process. And the streaming process, of course, is strongly tied to the advanced analytics and the traditional BI. And the way that everything happened with every tools that they built themselves or they bought from somebody and labeled it Oracle, is they actually integrated into the ETL process they call Oracle Golden Gate. They do the ETL on traditional data and also on structured data. And also they integrated the whole Hadoop into their whole system. They call it big data appliance. And then they utilize all the tools within the Hadoop ecosystem that works really well with their own process, although still very expensive. But it serves the purpose, and we still have. If a company decides to go everything with Oracle, they can still do it. The traditional BI, the advanced analytics, the streaming process, they'll work really well within the Oracle ecosystem, and they can still utilize the existing Oracle data governance piece. So, if you can pay more, you can still get the same results. Now I talked about the most expensive tools in the industry, and I think it's only fair if I talk about something from another great company, Google. And Google, they have a totally different approach. And they call it Google Cloud Platform. And their process is all based on cloud. And there are actually two other companies that are more they're also cloud-based and more enterprise-friendly. They're Amazon AWS and Microsoft Azure. And the reason I'm bringing Google out here is because I personally love the vision that Google laid out there. And what it is Google actually want us to be more service-oriented. They want us to forget about servers, forget about database, and just use their service use analytics as a service. However, we know that a lot of we're talking about enterprise today, right? And a lot of the enterprise, they can't just dump everything they have today and just go to Google and use everything they have, even though we know Google has the latest and the greatest machine learning tools, and it's good, but that's not good enough. So what Google is doing is actually they created something they call building blocks. They know what they have is not perfect, but they want to get us there. So that's why they laid out their product in a way that we can use different levels of their product to implement what we call the advanced analytics in the enterprise. So let's look at all the tools in different layers. The first one is, of course, the foundation. We have the compute engine, we have the cloud storage, so that's the servers and the file storage system. So if you want to just use Google as a infrastructure as a service, you can do it. And if any of you are familiar with AWS or Azure, this is no difference. All right, so that is the foundation. And then on top of that, we have database. The database, there are two kinds of database. The first is the data store, which is a relational database, and of course that's Google's solution for relational data. And then we have the big table. Big table is actually a key value store where you can store semi-structured data, and it's actually the origin of a more popular NoSQL database, HBase. So HBase originates from big table. So Google has a relational solution and a NoSQL solution for the databases, and of course they have the Cloud SQL on top of that. So you can access your data using SQL language very efficiently. So those are not something new, and we get it everywhere, right? And the next piece is the analytical and machine learning. This is what Google is really good at, right? Google, we all know that Google is very good with machine learning. They just built a machine that played with the best Go players in the world and actually beat them. And what's behind it is all the nice Google machine learning tools. And they made some of the tools open source, and they also integrated into their services. And a great one is called TensorFlow. That is their main platform for their machine learning. And also a couple tools I wanna point out here is BigQuery and Cloud Database. This BigQuery is actually a Google implementation of the concept of Hadoop. So Google has its own way of implementation. We can use BigQuery just as the way we use Hadoop. We have the data is stored and self-multiplied, and then actually we have by using BigQuery we can access the data really fast, extremely fast. And there are more value added to BigQuery is actually it's a very good way for you to publish your data and publish your analytics. That way we can actually use the BigQuery as a we can call it an analytics data mart where we can share data and share analytics. And I think that is in line with Google's vision that we want to be able to achieve collaboration between all the different organizations and all the data scientists, so we can achieve the goal of you probably heard the term many times. So we can have true citizen data scientists. All right, and there's more. On top of BigQuery, we have all the APIs. And we all know that Google is very good at doing like translation, like image recognition, natural language, sentiment analysis. They have already done it. They have the data to support it. And instead of giving us access to the data to do our own analytics, they actually create the API, which is free and everybody can use it. And Google is planning to do that more and more and give us APIs so we can use. So we can truly use analytics as a service. The last but not least, on the data handling framework, we want to be able to use the data, the Google platform and Google APIs easily, right? So Google actually created the data flow, which is a pipeline for you to use their products and use their services very easily. We don't have to write a lot of code. And even data scientists, you can learn to write code very easily. And Cloud pops up is just another, we can say it's a Google version of Kafka where you can send messages within the organization. And Cloud Dataproc is another tools that is used for you to channel data from from A to B and then to do your analytics. All right, I feel I talked a lot about Google because I really like their vision, and I think Derek, our second speaker today, talked about invisible computing, and I think that is in line with what Google is doing here today. Is they really want you guys to forget about servers, forget about database, forget about IT, and focus on analytics, and that way you can with least training and learning, you can do a lot of more things. This is just another way of looking at all the Google services and products. And I'm not going to go into the details, but as you can see, explain all the tools Google has, and you can dig into more if you're interested. And the reason they call it stepping stone, this is very, there's one story I would like to share, is actually Eric Schmidt, the former CEO of Google, said in 2008, he agreed that Google does not have a good enterprise strategy. They think way ahead of time. In 2008, they were thinking of analytics as a service. So that is why they feel that they're losing market shares, and they want to go back and bring and build all the stepping stones where an enterprise, no matter where you are in cloud strategy, where you are in using infrastructure or platform as a service, you will have a way to get into the end goal of advanced analytics as a service. So that's why they build all these stepping stones. All right, that's it about products. Let's come back and talk about best practices. The secret sauce, how an enterprise can succeed using all these methodologies. And the first one is align analytics with specific business goals. You should always have a goal in mind and have a use case. Build the use case and then the analytics and then the infrastructure. You don't want to do it the other way around. That way you can achieve your goal faster and cheaper. Ease skills shortage with standards and governance. What the hell is this? This is actually talking about the talents within your organization. You want to utilize whatever you have today in terms of people. Is your shop a database shop, a programming shop, or a data analysis shop? You need to first answer this question so you can have a better strategy on how to utilize the existing talent and then you select the tools that is most suitable and build the whole infrastructure. And then you can make it a standard and put governance around it and grow from there. Optimize knowledge transfer with Center of Excellence. Center of Excellence has been a very common practice in corporate for years, and big data or advanced analytics is no difference. What it is actually an organization within the organization for people that are working on different technology. Emerging technology, but it's for people in different departments that works on the same technology to get together so they have a platform to share knowledge, share resources, and build best practices. So that's what a Center of Excellence is. Next one, top payoff is aligning unstructured with structured data. Think about it this way. All the big data projects or advanced analytics is no different than your traditional BI projects. The business goal is the same. And the only difference is the data structure may be different, but you're still trying to achieve the same goal. So if you work closely with your traditional BI project, look at your structured data and go from there, then you can easily pick up the low-hanging fruit from the tree. All right. Speaking of picking up the low-hanging fruit from the tree, I want to bring up a project that was really successful with a lot of companies in the past, which is the data warehouse offloading project. A lot of the companies, they build data warehouses in traditional database, and then at some time it'll get to the limit, and you have to pay tons of money to upgrade it. It's either Oracle or Teradata, and you have to pay the money. And it's very common practice for you to spend half of the money to implement a NoSQL environment or Hadoop, and then you can have an environment to store a lot more data, and of course the performance might not be the same as a relational database, but it's perfect for you to store historic data that is not heavily used. That way you can offload your traditional data warehouse, and then you can reuse it for more updated data. That way you you're actually using the budget you're going to spend on structured database and build your unstructured platform where you can do a lot of bigger things. Next, plan your discovery lab for performance. So data scientists needs to keep this in mind. Analytics, they are all experiments, right? But we need to keep operationalization in mind, and we need to be able to, once these analytics are, we have proved the concept, we need to roll it out and scale it out for production, and then increase the performance. Last but not least, align it with the cloud operation model. I talked a lot about cloud and the Google station, and this is actually something that a lot of the companies are looking into, is the cloud operational model. Why? Because for the analytics, there are always two results with analytics: failure or success, right? If a project failed, then we need to shut it down and move on to analyze something else. If you succeed, then of course we need to operationalize it, make a product, and then we have to scale the infrastructure. So the infrastructure that supports it really needs to be elastic. And how elastic is a cloud platform? So that's why a cloud operating model is very popular, and that is the trend. And I know here a lot of you guys are still students learning data science, and one day you want to go to the enterprise, and you actually find a very good door to success. Data science is the door to success, and I want to say that cloud is actually key to this door, is because you can look at this in two directions. As a student, there are a lot of tools that it's in the cloud, and you can get yourself familiar with it. It's not expensive, and you can learn a lot of the concept. And from the enterprise side, this is the trend. A lot of the tools that they're using, there is a cloud version, and they're actually offloading a lot of their processes from their premise to the cloud. So that is why I said this is a great key to the door to success. All right, thank you very much. That's it. If you have questions, thank you. Here's my email, and you can follow me on Twitter, and I have a blog. You can follow me on blog. And I guess if you have questions, I'll see you guys, some of you guys in the afternoon. Thank you very much.